Okay, so today what we're going to talk about is 3-6, which is compound inequalities. And we're going to break this up in 2 days, but we're going to talk about lesson objectives to solve and graph inequalities containing the word and as well as we're going to talk about how to graph inequalities containing the word or. Okay, no academic standard for this time. Okay, the compound inequality is an inequality that contains the word and or the word or. So it's going to use like x is greater than 2 and x is less than 5. Okay, so let's look at an example of this. We have the word and. It says x is greater than or equal to 3 and x is less than or equal to 7. Okay, so there's that word and in place. Now this is 2 parts, so we're going to break this down to start. You're not going to have to do this all the time, but I really would like for you to start breaking it down. We're going to look at it first piece, x is greater or equal to 3. Okay, so what we're going to do is we're going to put our closed dot on 3 just like we would do before. And we're going to shade the direction we should. So what values are greater than 3? Well, we're going to shade this way. Okay, what value is greater than? Also, it's letter, symbol, number, so it's saying shade this way. Arrow's pointing that way. Now the next one, the and, says x is less than or equal to 7. So we're going to put a closed dot on 7. And then it's telling us to shade to the left. Okay. Now what happens here is that we're talking about an and statement. So what we can do is we can trace this down. We can trace this 7 down. Sorry, not the straightest, but we're going to trace this down. And we're looking for that and statement. So where do you get this and the other at the same time? Well, if you look at this side, we have values here, but no values here. So there's no and. On the left, we have values, no values here, but we have values here. So there's not that and. But here in the middle, we have values here and here. So there's that and statement. So we want a closed circle on 3, a closed circle on 7, and then what we want to do is shade in between. Okay, that's where the overlap. So really what we're looking for in the and statement is where the overlap is. Now the other thing is we have 3 is less than or equal to x and x is less than or equal to 7. So a compound inequality for the and statement can be written as one big inequality. So we actually have 2 of them. Okay, the and statement is the only time that you can write them together. And it goes smallest number on the left, variable in the middle, largest number on the right. It has to go that way. Smallest, variable, largest. And because of that, the arrows should be pointing left. Okay, the arrows should be pointing left. Okay, up here the arrow is pointing to 3, so down here the arrow is pointing to 3. Up here the arrow is pointing to x, so down here it was pointing to x. Okay, so that's the way it should look. Alright, so let's look at problem number 1. It says, what compound inequality represents the phrase? Okay, all real numbers that are greater than -2 and less than 6. So let's start by making a variable, so let's say x. We want all the numbers, all real numbers, so all real number x, that are greater than -2. Well, that's simple. Greater than -2. And, so we're going to use the word and to start, less than, and less than 6. So we're still talking referencing the x. Okay, and is less than 6. So x is less than 6. There's our statement. Now we can write this as an inequality, all one compound inequality, by putting the -2 because it's the smallest first, putting the variable in the middle, and then putting the 6 on the outside, on the other side. And then we just say, well, what's pointing the arrow down here? It's pointing to -2, so we put the arrow pointing to -2. Here it's pointing to the x, so it needs to point to the x. And there's your compound inequality. Okay. But we want to put this on a number line as well. So all we're going to do is we're going to put -2, -1, 0, 1, 2, 3, 4, 5, and 6. And it says we want values less than 6, greater than 2. So it's kind of like field posts. We want to be in between the field posts. So here's our post, here's our post. We're going to shade in between. Okay, this is on AND statements though. Okay, OR statements are going to be different. We'll spend another day on that. Okay, so here's a problem on the bottom. Think carefully. It's not exactly the same as up here, but very, very similar. Okay, I want you to graph that one as well. Okay, write it. Write the compound inequality. So I want all three parts here on your notes. Okay, so let's look at problem number 2. Solving compound inequalities involving the AND. Well, we have an equation now kind of mixed in there. So what we're going to do is we're going to write -3 is less than, so I'm just going to copy the problem down so we can see it. There's two parts to this. So what we're going to do is we're going to break up the first part. So this part right here, the first inequality and both sides of it. So I'm going to write m-4. And then the second inequality, which is I'm going to duplicate, so there's going to be some duplication. m-4 is less than -1. So really it's a two-parter. What we're going to do is we're going to solve for m just like before, add 4 to both sides. That makes m, sign doesn't change because we didn't multiply or divide by negative. So that's 1. Okay, over here we're going to do the same thing. And we get m is less than 3. So what we get is 1 is less than or equal to 3, or 1 is less than or equal to m, and m is less than 3. So what I'm going to do is I can bring this back together. Again, I'm going to put the 1 here because it's the smallest, the 3 on this side because it's the largest, and my variable in the middle. Well, I said m was greater than, or 1 is less than m. m is less than 3. So all I did was bring this together and my m in the middle. There's my inequality. Okay, all together. Or up here as an AND statement. We could actually write it like this as an AND statement. But in one inequality would look like that. Okay, so let's look at how to do solving a compound inequality by a story problem. To earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusively. Okay, you scored an 86, 85, and 80 on the first 3 tests of the grading period. What possible scores can you earn on the 4th and final test to earn a B? So let's start thinking about this. Well, what I need is I need a score between 84, so I want it to be the least that it could be, and the greatest that can be is an 86. Inclusively means that or equal to. Well, we're talking average, so I want my average to be between that. Okay, so this is kind of your setup. Well, how do we find average? Okay, well, average we find by taking 86 plus 85 plus 80, which is my first 3 tests. Add that with my last test, so we'll say x, and we're going to divide that by how many tests we have, which is 4. Now when we get done with that, it needs to be between 86 and 84. So we're going to add up all those together, and we get 251 plus x, and that's all over 4. So we have this number here. Okay, so now we're just going to do what we talked about. We're going to set up 2 different problems. We're going to start off with 84 is less than or equal to 251 plus x over 4. Okay, we're going to set that problem up, and then what we're going to do is we're going to set up the other one, which says that 251 plus x over 4 is less than or equal to 86. Now all we have to do is multiply by 4 here, which means that we get 336. Okay, so we're going to multiply both sides by 4. It's going to cancel out the 4's on this side, we get 336 and 251 plus x. Okay, then we subtract 251, and that means our lowest score can be an 85. Okay, if we subtract 251 over to here, it's 85. Same thing here, we're going to multiply by 4. So we get 251 plus x is less than, since it's a positive, 344. Subtract 251, and we get x must be less than 93. Okay, so for us to get an between an 84 and an 86, we have to score from an 85 being the lowest to a 93. Now again, this is to get a B. Obviously if we score higher, then there's potential that we're going to get an A. Okay, but again, we just set up the formula as being average, and then we just set up the two problems. The left half, which is these two parts, and then the right half, which is these two parts. Okay, and then we just go ahead and solve. So there's our answer. Okay, interval notation is a way to quickly describe the solutions of an inequality. Okay, so it's just a way to write it real quick. So that last problem we said 85 to a 93. Well, to quickly write that, we can write that as being a bracket, which means including the 85, to 93, including 93. Okay, if we didn't want to include those values, we would say parentheses, which is not including, and that would mean that we go to 85 but not actually including 85. Okay, so that would be less than but not equal to. But this is a quick way, so we're saying values between 85 and 93. That's what interval notation is. Okay, so what is the graph of -4, including -4 to 6? So all we want to do is graph this. So we just put -4. I'm going to put 6. Okay, we should have some values in here, but I'm kind of shorthand it for you. Okay, what goes on -4? Well, it should be a closed circle because it's a box, it's a bracket. Okay, so it means include. On 6, it's open, so we leave it like that. Okay, so there's our graph. It's saying that we want all the values in between here and here. Well, this looks a lot like an AND statement. So how do we write this as an inequality? Well, we went from -4, it's less than or equal to, and then some value, well, let's use t from, excuse me, not or equal to, because it's the parentheses in this case. Okay, so we want to go to 6. So what this is saying is what's over here. -4 including, 6 not including, everything in between. So these three statements all really mean the exact same thing. So these are different ways you can write it. Okay, we're going to go ahead and stop there for today. We'll pick up with the OR statements tomorrow.